Hi, welcome to Cloudtechs.club. So in this lecture, I'm going to discuss about the Kubernetes, its little bit history, and the architecture of Kubernetes cluster. So Kubernetes is a open source container orchestration tool which was designed to automate the deployment, scaling, and management of containerized applications. So you can think of containers as small portable environments for your applications. Kubernetes automates the process of deploying these containers, make sure they run smoothly, they can handle the loads, and can recover from failures. It organizes containers into groups called pods and ensures they have everything they work properly, such as storage and network connectivity. Kubernetes provides features like load balancing, storage orchestration, automated rollouts, rollbacks, which makes easier to manage containers across the production platforms. If I'll talk in terms of its history, Kubernetes was originally authored or developed by Google. Google was using Kubernetes within production environment from year 2003 with a name called Borg. The technology name was Borg. Later, this Borg was donated to Linux Foundation, the CNCF community, which is rapidly becoming the leading platform for managing containerized applications. So, if I'll talk in terms of its architecture, it consists of two components majorly. One is master node, another one is your worker node. So, master node comes with various components, while worker node works with few other components. Master node consists of API server, scheduler, controller, and etcd server. So on the left hand side, you can see the master node. And on the right hand side, you can see two worker nodes with its components. So in case of master node, the API server, scheduler, controller, and etcd database can be set up on a single node, or it can be set up on a different nodes as well. In productions, generally it is recommended to use different node for the etcd database while maintaining the high availability for the master nodes. Here you can see I have kept scheduler, controller, API server on a single node and etcd database on a different node. On the right hand side, we have worker node. In Kubernetes, every container runs within a container, which is also known as pod. So it's a virtual boundary across the container. In Kubernetes architecture, every component talks to each other via service API server on master node. Please note, no component will talk to each other directly. They have to go from API server. It's a middleman for all the services, for all the components to talk to each other. Let's see how it works in the background when you hit a command or when you would like to schedule a simple pod in the cluster, how it works in the background. Let's say Kubernetes administrator wants to deploy a simple pod or wants to schedule a simple pod on top of the worker node. So what will be the workflow in the background? So Kubernetes administrator will run the command from here, which will hit to API server. And this request will be forwarded to scheduler in the background. Now, it's scheduler's responsibility to identify the node where this request can be satisfied or on which worker node the pod can be created. Let's say scheduler decided to create this request on worker node 1. The scheduler will connect with kubelet component running on worker nodes via API server, as all components talk to each other via API server within Kubernetes environment. Now, it's kubelet responsibility to create the pod, while container creation will be taken care via container component. Here we are using container component as Docker. This container component can be a Docker or Rocketd. It depends on the basis of requirements. This Docker container or Docker component will pull the image from Docker repository or private registry, will create the container and inform kubelet on completion. Scheduler also connects with kubeproxy to provide required network configuration to pods. So all network related management will be taken care via component called kubeproxy for the pods running within the worker nodes. Once kubelet confirms the successful creation of the pod to scheduler, the scheduler will inform the database via API server about the pod creation and creates the entry in the etcd database for there is a pod which is running on worker node 1. It creates its entry in the etcd database. Same information from this scheduler will be forwarded to controller running on the master node via API server. Now, it's controller's responsibility to maintain running state of the pod during the failure incidents. Controller component always need to maintain actual and desired state of the cluster. When I mean actual and desired state, just suppose a container or a pod went down or damaged due to any technical reason within the cluster. It ensures to create a new pod within the cluster and verify that this was the request, how many pods I need to run, and how many pods I am running right now. So it will balance that actual and the desired state. So that's how the Kubernetes components work together to form the Kubernetes cluster. If you like this video, please go ahead, comment, subscribe, hit the like button, and share with your colleagues so that they can learn more about the Kubernetes. Thank you.